Section 2.1b is about something called absolute value. We're going to start by defining what absolute value is. The absolute value of a number is the distance from 0 on a number line. That's all it is. So if you have the absolute value of 6, we're really asking ourselves, how far away is 6 from 0 on a number line? And so if you drew a number line ahead of 0, you'd see that it's 6 units away. The other question is what to do if there's a negative. If I say the absolute value of -3, what I'm really saying is how far is -3 away from 0 on a number line? And the answer would be 3 units. So notice what happens here. Whenever you have the absolute value of a number, your answer is always positive. That's because a distance must be positive. Down here's a key or a note. A distance cannot be less than 0. And that's really the key when dealing with absolute values. Whenever you have an absolute value of a number, you cannot get a negative number because a distance can't be less than 0. Here are a group of examples that use absolute value, and they're all fairly simple. The absolute value of -7, the distance from 0 to -7 is 7. So whenever you have an absolute value of a negative, it becomes positive. Over here, how far is 18 away from 0 on a number line? The answer is 18 units. Some people mistakenly have the idea that when you take the absolute value of a positive number, it turns it negative, and that's not true. Every absolute value of a number will be positive because remember, it's talking about a distance. So what's the absolute value of 7/9? It's positive 7/9. Absolute value of 2.5 is 2.5 units away from 0. Absolute value of -2, positive 2, and absolute value of -5/6, positive 5/6. Here we're being asked to evaluate an expression, and that expression includes an absolute value bars. So let's see how to do that. First of all, we're told that x equals 8. So we're going to do what we typically do. We're going to take that x equals 8, take the 8, and we're going to substitute it in for x. So I'm going to rewrite this. 15 minus, instead of x plus 4, I'm going to use an 8 plus 4. Now the absolute value bars not only represent a distance, but they also work like parentheses. So in this case, we're going to do the 8 minus 4 first. Excuse me, the 8 plus 4 and get a 12. Now we have to ask ourselves, what is the absolute value of 12? Well, remember, absolute value means a distance. The distance from 12 to 0 on a number line is just 12. And then 15 minus 12 is 3. Here we're going to evaluate some more expressions with absolute values. We'll rewrite this one as 57 minus absolute value of x, which is 18, plus 34. Remember, the absolute value bars work like parentheses. So this becomes 57 minus the absolute value of 52. Absolute value of 52 is just 52. And then 57 minus 52 is 5. Next one here, absolute value of z. Since z is negative 0.76. And then the absolute value of 0.76 negative is 0.76 positive, because remember, absolute value represents a distance. And then 0.76 minus 0.26 is 0.5. Last one in this group says 19 plus the absolute value of 21 minus y. Y is said to be a 4. We do what's in the absolute value bars first. 21 minus 4 is 17. Absolute value of a positive stays positive. So 19 plus 17 is 36.